Good morning, everyone. Today is October 27th, 2018, and this is the John Chappell Natural Philosophy Science Chat. I'm your host, Franklin Hu, and please support us. You can find our website at naturalphilosophy.org, and you can join us. And we have lots of places that you can participate. We have a natural philosophy forum, and also join us in social networking on our Facebook page. And we also have our YouTube page where you can find recordings of these science chats as well. And if you'd like to help us, we invite you to go to Basecamp and help us grow. So one of the benefits of our society is that we sponsor a yearly conference. This year, our conference will be at the University of Washington, June 26th through the 29th. And our keynote speaker will be Gerald Pollack about the fourth data water. And Dr. Gerald Pollack is a regular, University of Washington professor who will be speaking at our conference. Okay, so today our special guest is Paul Schroeder, and I believe he's going to be talking to us about infinity and realities. So let me go ahead and put your paper up, Paul. And let's see. I'll let you take it away. Go ahead, Paul.
Okay. Obviously, or in any case, in my time, I have been interested in creating getting a different system of the universe. I'm getting feedback here.
Yeah, you're getting a little bit of an echo. You might want to. Well, that's kind of weird because you have to turn off like your computer audio.
Okay. Yeah.
Something.
Yeah. Maybe I can just. I'm holding onto the phone here. Maybe I can talk just into the phone system itself.
Well, you could try again to just talk through your headphones. And maybe they started working.
Yeah. Can you hear me talking to this? Talking to the phone itself.
I can hear you talking for the phone, but I would suggest that you just listen to your headphones and see whether you can hear us now. It sounds like the sound is coming through your headphones now.
Yeah. Okay. I'll use my headphone then. And I can hear you through my phone, so that's good.
Well, can you hear us through your headphones?
Yes.
See, so now it decided to start working then. So you don't need the phone anymore if that's the case.
I'm sorry. I do not need the phone? I need to talk.
Your headphones, you don't need the phone.
Well, how do you? I'm talking to my phone right now. Why don't I need it?
Well, stop talking to your phone and just listen to your headphones for a minute.
Okay, I don't have my headphones on, so come on.
That echo's got to be coming from somewhere, and I suspect.
Okay, I hear you on my headphones.
You hear me on your headphones?
Yes. Do you hear me?
You can hang up.
Oh. I wonder why this fixed itself.
Yeah, why did it fix itself? Who knows?
My goodness. Okay. So now I can just get started, right?
Yep. Go ahead. Get started.
Okay. The paper is Infinity and Reality. It's the first of a set of three papers covering my universe's otherwise theory. These were written back in 2016, 15, 16. In any case, the universe...
Looks like you can hang up your phone. Looks like you're still on the line.
I hung up my phone.
Or did you? Okay.
Oh, is it hung up now? Hello?
I think, well, it still shows. Are you come dialing at 7086?
I'm sorry. I hung up the phone. I'm sorry. What's happening here?
Okay, that's fine. Be someone else dialed in. Go ahead.
Okay. Okay. Hopefully the phone is uninvolved here. Any case, we'll try again. So I have had a theory for a long time about the universe. It's pushing gravity based, and I don't have any influence, so it's one of the things that interferes with me going anywhere with this system. But there's a second thing that other people here also have their own theories, and I don't think much of anybody can break through the whole concept of the standard model, and that in itself is a problem. And you can find out all kinds of little things that seem wrong with it. And my theory here, and the reason for this paper, is that I think the first thing that has to be done is to take care of the whole point out all the problem with the fundamentals of the standard model. And the primary fundamental is that it's finite and not infinite. Now, we'll start the paper. Infinity contradicts current cosmologies. Overall understanding of cosmology would be altered, improved, simplified by redefining the universe as infinite in space and time. Now, we don't have to redefine the universe, because if you look up a definition, it says that the universe is the whole body of things and phenomena observed or postulated. In other words, the universe is everything. And so the standard model, or basically the Big Bang, has violated the definition. And that's a lot of what we're going to run into in this paper. Introduction. Let's discuss the overall nature of the universe, or two perspectives. The universe is either infinite or it has boundaries. In thinking about universe, or the infinity, you look forward and say, well, is the universe going to continue forever? Or will it end somewhere or sometime? There are two possibilities. Space and time are involved here. If you decide it won't end, you choose an infinite future. And a lot of people may do that at this point. Like in the year 2510, that song, things don't start over again. But infinity works both ways. And there's only one universe, and calling it infinite implies there's no beginning in space or time. And a lot of people, that's a problem, because infinity requires revised view of reality. The universe is all space, and it's a container for everything. You either picture the universe as endless without a beginning, or picture it as finite. The idea of a finite universe means there is a beyond, whether in space and time. This bounded theory requires edges, where the universe ends, and ultimately an infinite number of infinite edges provides an infinite number of opportunities for people to speculate about what's going on at the various edges. And the whole point is we're addressing the Big Bang. That is dealing with one of the edges of the universe, the beginning. There's nothing before, gradually something expanding in size, expanding in content, and that makes no sense in infinity. There are other mystic and discounted physical models that flourish without concern about the universe itself. Space and time have lost their reality, and multiple dimensions were introduced. And that doesn't make that again is a problem with logic of the definition of universe. This is a document redefining the nature of the universe. A different universe with a new paradigm requires rethinking and repackaging all of the existing knowledge. The point is that, or one point here anyway, is that they require that papers have some experiments or some mathematics or something that ties in with the existing theory, and you can't do that to get somewhere else. What you need is a whole new perspective that then attaches to all the things, either attaches or rejects all the things that are logic or known out there at the present time. Anyway, you may incur revelations associated with infinite view. Acceptance takes a long time. Cosmology based on the infinite, and the current one is based on the finite universe, are incompatible. Comparing them provides a mental exercise. The infinite universe gives a gravity of physical nature, which it doesn't have today. It's metaphysics. All infinite universe stimulates incentives to restudy things. If you're going to get to an infinite universe, you're going to think about rotations and mass, the nature of space, orbiting, gravity, light, EM radiation, so forth. Relativity made headway in those directions. This system further connects space and mass. And we ultimately, going through my system, we get to the point where space affects mass and mass affects space. Similarly, like it was a part of Einstein's primary formulas at the end. Okay, we're going to do beginnings and endings. Our local environment is logical and ordinary, just your yard, your sky, and why would cosmological views about distance and space be different and make the universe mystic? Why should things be different far away and long ago? Our path re-examines beliefs upon our science today. The big and small sizes, the close and far distances, short and long time frames are either bounded or infinite. And this paper obviously says they are infinite. In the bounded view, there are end markers and beyond the beyond to deal with. There are beginnings and ends to account for. Whenever one imagines beyond the end lines may be produced. Today's theories accept boundaries. Today's theory, again, being the standard model. Continued development of the Big Bang and expansion has dominated cosmology. Within the standard model, speculation of new concepts is encouraged. Although finite boundaries do employ more researchers, that's the point. There's money involved here. There will be many new perspectives to pursue if you accept infinity. Infinity cannot be assigned to most things. There's no specific infinite motion, for example. The infinite is the universe. What is the universe? It contains all matter and anything else that has forms, as defined at the beginning. It is the volume of space as defined by the whole XYZ coordinate system and go extending infinitely in every direction. Finite is bounded at one end with a beginning and bounded at the back with an end. Does the universe end somewhere beyond our imagination? So today we have the Big Bang as the creation of the universe, followed by ongoing extension of existence. There's also the concept of time. The Big Bang assigns time a beginning boundary. So time, size, and distance are the things that can be infinite. Other things, everything else is contents and cannot be thought of as infinite. The universe and time are both virtual ideas, not real physical things, so they can be infinite. Space is real, and Einstein merged it into his four-dimensional space-time with it. That results in space losing real form and the ability to provide measurements. Space, as we understand it, is real. Thus, it has to be made of something that gives reality to measure. So a void in space cannot exist, as it cannot extend any measurement of that space. So space is real. Space provides a place for the transfer of things and assists motion. Motion has its origin as an action, of gravity, and it reaches across space. The contents of space. Okay, so what is space made of? Well, the first thing that we know space contains is gravity, that force. Now, exactly how that exists is what's never been well described. The Big Bang Theory gravity didn't even exist until well into the expansion of time, and it grew from there, which is weird because that means the content of the space didn't even exist. Many edges have been defined for evaluation in so many ways, and science keeps seeking beyond limits. And some of this came from the fact that we like to think back on mankind, and we want to find out. We want to look as far as we can at the components of space. So we're sort of looking for the beginning when we're looking at things earlier. So religion kind of played a part, accepting the Big Bang as a replacement for creation because it says in the beginning, and that's a problem. And that summarized God's revelation to mankind. So the Bible is sort of a history of us leading everything forward from some beginnings. Night and day, mankind, they all had beginnings. Everything material does naturally end with a beginning, or has a beginning and a time in space. Man and earth, the sky all have beginnings. It is the universe itself where measurement resides that should not be assigned a beginning. Religion doesn't assign a beginning or an end to God, so God is apparently infinite, just like is he the universe within which all things exist. Biblical ideas are actually more in tune with the infinite universe than they are with the Big Bang, even though they seem to promote the beginning of things. Infinity allows the assumption that everything beyond local arena is similar to what we know locally. We can relate to our local neighborhood and simply extend our current logical understanding of matter and effects and size and so forth, such as motion. Someday physics, logic, and cosmology will revert to and accept a simple infinite universe, maybe. As a sidelight, it's interesting that mathematics, in its process of working in this finite universe, has created a procedure for eliminating infinities to accept boundary investigation. if we got to infinite universe, that would things like the hadron collider would be less useful. I mean, it does find some nice small things, but it would not define the universe. The Higgs boson wouldn't be a universal particle. Extra dimensions arising from the expansion theory would go away. Accepted theories don't hold water if space and time are infinite. Absolutes. Theories built upon some logic base that separates findings of one model from other models. We all think different. Everybody has different perspective. We view the universe as black and white or gray, but our models depend on some physical concept value to build upon, and relativity demands a fixed and limiting velocity for light. That choice has led to many debates over the years. Light also is fixed with a massless structure. Finally, and so, that created those couple standards of current theory ran into plenty of problems, some of which have not been looked at yet. But the massless structure of light and radiation finally needed some kind of something that responded to force, and they had to come up with a photon. Einstein did, and so those are a piece of relativity basics on theory. Newton had certain basics in his theory that essentially that space is empty. His three laws refute any beginnings correctly. But within even an infinite universe, all the contents must have beginnings. It's only the base that goes infinitely. Newton's handling of motions of orbitals implies absolute continuation of that motion that is therefore bent by the gravity is infinite, and that's not reasonable because you cannot have infinite of a motion, and motion cannot be infinite, absolute. Relativity accepts Maxwell's views of light velocity c as fixed and dependent only upon its medium. No gravity or other causes are allowed to affect light velocity. So c fixes the geometry of space for relativity. This theory assumes that all distance can be measured by time travel of light. A little bit, the situation is that my model does away with these couple things that we've mentioned. It does away with any voids. It does away with the speed c absolute fixed for light, and it does away with the radiation not being affected by gravity and needing the photon and in some way being different from matter when radiation is really acts similarly with matter. Next section is space empty. Space has to be real. It can't be empty vacuum. It wouldn't exist. From early times, Aristotle to Copernicus to Galileo to Tycho Brahe, mankind studied space but had little interaction with space. Everything was just thought about. Gravity was centered on the Earth. The Earth caused gravity. Galileo provided tests of gravity for us. Copernicus identified orbiting motions within our solar system. Tycho Brahe diagrammed the orbits which with relation to Earth. Kepler gave a partial explanation of the orbital motions, which finally implied a motion source related to the sun. Okay, this is important. Somehow orbiting is related to and sourced by what is being orbited. Why do orbits exist, and what does the motion within orbits continue unchanged? Why does it continue? Why don't bodies fall away, or why aren't they slowed by friction? Motion continuing unchanged implies empty space. So again, going through Newton, his explanations, he then figured out how to apply the gravity seen on Earth to space. His theories led to interactions of spatial bodies and of all masses. In order to propose ongoing centripetal gravity force, he supported orbital motions, or that supported orbital motions. He had to cause all his readers to overlook any friction. And the point is, and he stresses, there's no friction out in space. And he did his 3 laws of motion. A body at rest remains at rest unless externally affected. The body motion continues unchanged, and unless interfered with. And finally, interference by other moving bodies imparts new velocity and direction of motion to the bodies. But again, there's this infinite motion out there, and it would be affected by the friction if there were friction. And in today's world of technical and detailed knowledge, the absence of friction idea needs to be discarded in favor of an ongoing impetus from the center that drives orbiting. Newton's views competed with the overall and overcome the whirlpool theories of Descartes as a source of orbital motion. A whirlpool representation of motions of space itself didn't measure as predicted by the central spin experiments. In other words, Descartes couldn't prove his theory by relating it to spinning fluids in a bucket or rotation within a fluid medium, because the squared and cubed of the motions didn't match up right. In neither example do the velocities or actions of the fluid simulate the orbital velocities, and that led to disinterest in Descartes' model. What's needed is a more extensive examination of the environments in which planets revolve, and how the effects are related to the central source. Friction was discarded. But there are meteorites, solar wind, light is now known to cause some pressure upon Earth and upon eyes, and therefore upon the orbitals. Newton proposed dual forces by which gravity maintains orbital motions, with gravity attracting planets, and the perpendicular offset was the original ongoing infinite motions. Somehow everything always exactly offsets, and these are just 2 perpendicular pieces of the offset. Without a motive force, that's all you get. There's a scary thought of collapse if equality is broken by friction or something. Cosmological knowledge accrued from our central personal perspective. Mankind lives on Earth, so therefore everything was related to Earth. Theory was that matter dominated, was the dominant and versus space. Like Tom Van Flandern suggested that we imagine the creation of the universe from one starting with one universal sphere, and then you gradually add space to it, space, and and ultimately out there somewhere you get to somewhere, and you add other things, so that again the Earth was dominant of everything. But the reality is that when we actually get out there and think from space toward Earth or toward other matter, space dominates the matter. Matter is just a content within space. Our collected knowledge has been oriented incorrectly. It's time for orient it to space itself. A motive force that creates the motion of the orbitals is required to offset the centripetal inward gravity effects. The motive force is actually supplied by gravity that pulls the bodies together, so stability is guaranteed. And that's just touching on where all of my theories ultimately lead with the pushing gravity. Given that space is real, what is it made of? Gravity is a component. We don't view force as a thing that can serve as contents, so gravity must have a physical nature. Along with gravity, there is light passing through space. And so space consists of gravity and light. And so light has had the, light, okay, we'll talk a little bit. Light is obviously a radiation frequency within the EM radiation spectrum. Light became known as a form of radiation from work of Faraday and Maxwell. Faraday discovered magnets could distort the flow of electricity, and he proposed magnetism and electricity joined as radiation. Faraday recognized space was full of radiation and included the flow of electricity and magnetism. Since light flowed through space, it must be radiated waves. Light became the foundation of the electromagnetic scale. Spectrum based on the number of waves was formed. Maxwell believed in Faraday and created some mathematics for it. And included the idea radiation has a fixed maximal velocity. That's the C that led into, among other things, relativity. Maxwell proposed that gravity is not instantaneous, but has velocity of its own, and that's important. And that ultimately ties gravity into the whole electromagnetic radiation scale, but that's way down the road. Maxwell failed in his attempt to connect EM radiation with gravity, but he had thoughts about pushing gravity. Faraday and Maxwell focused on the flow of electricity and magnetism. Faraday found common in their flow. The two forces had flows whose waves are differently directed. Electricity and magnetism, therefore, in a linear sine wave view of the distortion of the waves, are a distortion of flow and jut off the line of flow in the XY direction. And they are in my drawing here, that in the in the XC direction for the flow. Define it how you will. There's three directions, obviously, in 3 dimensions. The choice of the offset plane determines whether the wave is magnetism or versus electricity. There's a third dimension, of course, which is the flow direction of the entire beam. So there's a beam with waves going off in a couple directions. Faraday and Maxwell thinking never really did include gravity. Gravity effects and magnetism effects are similar, so you would think and gravity must flow. So you can see that it can fit in the whole radiation scale. So then back to light now. Matter and flow of light is a prime focus of cosmology. Mankind has made important discoveries throughout the age studying light. So the EM radiation scale started with light. Light travels through space. The sun and stars provide that. But light is processed as massless, but there's pressure from light in certain situations on the eyes, on the earth, and the warming. The pressure concept led Einstein into again creating the photon particle as an imaginary thing, really. Light was massless by definition, but light waves have nature and move or flow forward. Everything that moves has a nature subject to gravity. Assuming only massive items were affected, formed a boundary limit that led to a constant speed of light. Okay, so light goes so fast that there was no way of really proving that light is subject to gravity. So therefore, it's something different from mass, and it needed a photon to be affected by mass, and the thinking kind of stops there, and then stays with the constant speed of light. Light beams are launched by a source star, like a rocket being fired upward. Gravity will cause a rocket to slow and possibly flow back to the surface. This is a little bit like last week's paper. Light moves so fast that for efficiency's sake, gravitational effects are always ignored. That allows the base C and limit to fit with relativity, and I'm sure they understand that there could be, that they're making statements of that at some infinite place, the theory gets modified because they've had to use C as being absolutely fixed. But speed can't be absolute. Light should be affected no matter how little by gravity effect. That source body remains directly behind the flow of the center beam of light for many light years. At some point, science must consider the trivial continual gravitational attraction on a photon against and relate that to the extensive time of these of light years that is happening. So redshift is best called a logical sign of some minor slowing of the speed of light. Stretching a wave into a longer beam causes fewer wave arrivals and thus a slower velocity at the destination. Gravitational slowing would substitute for this current Doppler view. Doppler's based on around trains and sound, and it was, it was the concept at the time, and so it seemed to fit into why there were redshifts and stars all over the universe. That led to the idea of expansion of space occurs between the source and the destination, with light velocity being constant. Correcting this logic, the source gravitation causes slowing of the beam, and that causes a redshift. There's more. The redshift is gradually overcome by the gravitational attraction of the destination star. That star pulls light, so it goes faster. The overall speed and appearance of the light beam is therefore blue shifted to compensate for the redshift of the earlier part of its flow, and it is. And so the two shifts are offset mostly each other. The fact of the second half of the flow can be connected to the Pound-Rebka test, where they go up in space and aim a beam toward Earth and find that the measure of the redshift is different at the rocket ship source than at the ground, and it is actually blue shifted some. So that's the same experience that happens by light sent from a distant star that gets redshifted along its way for a while and then subsequently blue shifted. This test is done originating light in space near Earth. Okay. So then this becomes an alternate to the Doppler idea of bodies moving apart and causing the redshift. And expansion is no longer a logical model of space in the universe, per me anyway. We claim that light redshift increases with distance, the distance of the source. With this variable light speed at some distance of light, the shift exceeds the visible red range. In 1826, Aubert proposed a paradox in which the night sky should be light from an infinite number of stars. But it's not. But essentially, he was correct. In a manner of speaking, the light has continually been redshifted. As the waves extended in length, they became infrared, microwaves, radio waves, and beyond. Appropriately, the isotropic microwave background is observed. That could be replaces light, signifying an approximate distance from which all light from very distant sources is shifted beyond the visible. All directions reveal a similar amount of starlight shifted into the microwave range. The background has been given a whole existence of its own called blackbody radiation. The cosmic background radiation is Olber's starlight ablaze all over. The background radiation has given a false impression of a boundary to the radiation, but actually gravity causes the redshift. Light beams act in a manner similar to matter. Light is subject to forces such as gravity. There's no need for a dual nature for the photon. All action of light, such as its impact and penetration, can be viewed as functions of its wave coil nature. It comes as a beam, and it has waves, which could also be seen as coils when you think about waves being more than just two-dimensional, they're three-dimensional. That's what that is. Light can be formed when spatial beams initiate interactions with mass particles. Spatial beams gain increased frequency. We learn how heavenly bodies such as our sun convert penetrating flowing beams. This is into my system further down the road. The sun converts penetrating flowing beams of radiation and creates and releases them as light and heat. In other words, something came in one side, came out differently. Its output is simply a converted form of the penetrating pay-up gravity beams passing through. We will also explain why EM radiation penetrates and the determining factors. Motion, absolute measures of motion don't exist because all motion is seen upon, absolute measures of motion don't exist. All motion is seen upon a particular field of gravity defined at any place. The universe displays by gravity which is always in motion. In other words, there is no absolute frame of reference for dealing with any displacement of one's location. The dominant activity of the universe is motion of celestial bodies relative to each other. With infinity fully addressed, our all-inclusive physical theory should focus upon spatial motions. Once the source of the motion is determined, the second level of interest becomes how do you measure that? And there's rectilinear translational motion, and there's rotational motion. And we subsequently get into some of that. Angular rotation motion is relative to a point and includes lateral displacement. Combining those two measures of motion for projectiles leads to difficult physical understandings of space. Function of separating the two is really sort of part of Newton's three laws. The fundamental difficulty in relativity theory is the transmission of light helps dictate the nature of space. And when the source body moves, you get some entanglement between the motions of the bodies and the signals and so forth. Light signals can be influenced by motion of the observer, which action is specified as aberration. Our corundum is light conveys a suggestion of source motion, while the motion influences the transmission of light. Nature of space. All right, I wrote a fair amount here on the nature of space, not really addressing what was in the previous paper, that the redshift discussed by gravity affecting light is different than the Doppler redshift, and therefore will redefine the nature of space. What this particular paragraph here discusses is the ether, which a lot of people use, and which is one of the steps that Einstein took in creating relativity by saying there is no ether, there is just empty space. And the reality is that, per my view, you really don't need an ether of, which gets complicated, is what does it carry, light or people or mass or nothing, and what is it different near mass or in mass or in empty space? What I'm saying is that you do not need ether because radiation from all directions creates the full structure of space. And as part of this whole thing for relativity, there was a Michelson-Morley finding that was used to eliminate the ether, and my view is that the whole M&M experiment was meaningless because what we tested on Earth was that the light wasn't changed as it ran along the surface of the Earth back and forth, its frequency did not change, and they related that somehow to the motion of Earth, either as either in its rotation or its revolution, its two motions relative to the sun. But that has nothing to do with what they're testing, because they're testing whether light retains its frequency in the sorry, in the what's the word I'm looking for? In the equilibrium. Okay, the bottom line point is that there is equilibrium laterally on all planets and all bodies. That's why they have been created and exist. And this, there is, as soon as you go up and down, you're bumping into gravity, and so that gravity is going to throw off any study of the frequency or speed or whatever of anything, including light. But if you do it parallel to the surface, that surface is achieved equilibrium, and it will just prove equilibrium everywhere. The way it achieves equilibrium is a major part of this whole understanding of gravity and how gravity gets involved in orbitals and rotations of bodies and so forth. What else do we have to say here? Earth exists because the equilibrium of impacting forces. Light can change frequency while crossing space. Light will change frequency in crossing space, but it will retain its lateral frequency on Earth. Equilibrium of cosmic body surfaces is a lateral situation. Gravity removes equilibrium, so that you've always got horizontal equilibrium and never have vertical equilibriums. Ultimately, the M&M test only proves the absence of aberration of the sun's light as it arrives on Earth. So in any case, the ether went away and that's come back and so forth, but clearly you got to have something, and I have radiation. There's radiation because we know that the sun shines everywhere and stars shine everywhere, and we know there's X-rays coming from all over the place, and you merge it all together, you got one big solid, semi-solid universe that is reality. You might think that, well, how do you get all these radiation from all over the place to create consistent measure in any point in the whole universe? Well, you got stars and sources of the radiation, whether they're still light or have been downgraded into microwaves and so forth. You got them coming from every direction upon any dot in space. Now, if they got any reality, they could be drawn and there might be space between things, but as soon as you look at the potential space between some crossing lines crossing any dot, time will have shifted the source a little bit, and that's the void goes away. In other words, you got voids that are continually going away, and you've got something that's like the Heisenberg's theory of uncertainty. Beams travel at near infinite velocity, but the sources are in consistent motion, so all receiving points will receive reality beams most of the time and enough of the time that it's never really gone away. Okay, so Science has observed that light going in one direction does not affect light going in other directions, which is another reason to agree to the fact that any point has got light from any and all directions creating its existence. Now, one of the problems you have is that if we really think in terms of real things as our beam, and you got beams coming from every direction, they do impact when they're 180 degrees exactly, or theoretically impact with each other and wipe each other out or something. And yet there's been a lot of attention to that concept. In one case, there's the net result is called a standing beam, in which the beam itself stops, and yet the waves that represent its nature continue to flow on and retain the speed c motion. It's a little similar, I think, to Franklin's concept of phases that come together that are the same phase or opposite phases, and opposite phases can continue, and same phases don't, bump and things merge together. But in any case, that's the end of this particular paper.
Okay, well, we can open it up for questions. So, Harry, you've got a question.
Okay, Paul, you've said a lot of things that raise issues. Can you summarize what the whole point is of what you're saying? I mean, I really didn't quite, you didn't really end with a conclusion. What's your conclusion? What's your point?
My conclusion is what I said at the beginning, that the standard model is a mess, and these are all things that are wrong with it. And not only all the little things that you find debating, relativities problems and gravity problems, you first have to start. In order to build a new system, you have to start by getting rid of the old system, and that's what the attempt is here.
Okay. Yeah. So is what you're doing science or philosophy?
Is it what? It's philosophy, yeah.
So you think you're doing science? Is that what you're doing? I can't tell whether you're doing science or philosophy.
I am using existing findings and concepts and putting them together in a different perspective. So therefore, it is considered philosophical, because I'm not and never going to add new experiments or new mathematics, because in order to get a new view of the universe, it's a case of putting everything that we already know together differently. Okay?
Well, that's assuming that we already know, that we really know what we think we know. But okay, so now that we've clarified the genre, then you don't really see necessarily that you have to build your system based on facts of experiments. You're talking philosophically and reinterpreting concepts philosophically. Is that correct? That's
it's kind of correct, and it's really similar to what Einstein would have had to do to create relativity in the first place. Yes, he did have a couple of experiments, but he falls back on things like the M&M experiment and so forth to essentially get rid of.
Okay, I understand now what you're saying, but now, okay, so the fundamental issues are you're starting off. I guess my view is that you're kind of starting off with the most difficult things first, or maybe not. You're saying basically that the concept of what is reality, i.e., the universe, needs to be redefined differently. Is that correct?
Yeah, well, it's defined okay, but it's not applied okay within physics. I mean, it's defined essentially as infinite, but then physics goes elsewhere and has.
Well, they're basically claiming that they're interpreting facts of experiment. Okay. Now,
with a Big Bang?
the issue is, are they interpreting the facts of experiment correctly? To me, that's what the issue is. So, if you have an experiment that says, okay, we have the Big Bang. Okay, so they have a theory, and then some guy comes along and he says, oh, I've discovered this microwave background radiation, and it looks like this was predicted by the Big Bang theory, so that makes the Big Bang theory correct. And so then they've decided that, oh, that's the correct theory because the experiments prove that it's correct. And that kind of is a flawed method of thinking, but they won't acknowledge that. Are you agreeing or disagreeing with that?
I think I made that point fairly clear that the microwave is further redshift from light from stars throughout, and therefore you get the similar look of microwave in all directions because there's stars. Yes, it's a totally different explanation of the microwave background. So yes, this
well,
is.
I was sort of asking more along the lines of, do you agree with the logic that they use, that they're in their conclusion? And I don't, to me, this is the issue. The issue is they have an interpretation that they put onto the facts of experiments based on their theories. And when a theory is said to match the experiments, they say, oh, yeah, that's correct. But they don't really look at any alternative theories or explanations. They just accept the one that they seems to arise first, and they jump on that, and then that just becomes, the established fact because they say so.
I agree with that. Yeah, that's what happens.
Now, you apparently have a different idea about, to me, the whole problem of infinity and bounded. What mainstream says, as I understand it, is the universe is finite but unbounded. And that causes a problem because people say if something is not bounded, then it's therefore infinite. So the universe, according to mainstream, could be finite or infinite depending upon what you think bounded means.
Okay, well, I tried to touch on all of those things with boundaries and so forth.
I didn't really quite follow what your point was.
My point was that the existing system with a Big Bang, the birth of the universe itself in their system is a boundary, and as soon as you have a boundary, you don't have an infinite universe.
So you're saying that if they say the universe is finite, then that implies boundedness.
I'm sorry, they say the universe is finite. That I say is a problem.
Right,
And
but
that's
what
why
they say is the universe is finite and unbounded, which is kind of in a way a contradiction.
okay, that's fine. You're right.
That seems to be kind of what you're saying.
I think so, and I think if you took something of the format of what I got here and added some of your perspective to it, because it's really very similar, I think, to mine. Uh, maybe it can be made into a stronger presentation.
Looks like Michael's got a comment.
Well, as far as a Big Bang starting the universe, or whether the universe is finite or infinite, I think, well, of course, I have my ether model, which is quite different all the way through. But in my model, the first thing that happened was a universal oscillation, and then breakdown of the perfect symmetry of the oscillations by a yin and yang combination of neighboring pairs of oscillating points, and then reversible reversion to singleton units, which are out of phase with the oscillations, therefore breaking the perfect symmetry of the oscillations. And from then on, you had vibrations, which were energic and directional and universal. And you don't have any question of infinite or finite, doesn't really enter into that. It's just everywhere. I mean, it's a universal oscillation that happened everywhere.
Okay, well, I mean, you get.
Sorry, but I didn't understand a word of that.
Okay.
Go ahead, Paul. I'm sorry.
Okay. What was I going to say? I forgot.
It's kind of hard to say something when you didn't really understand what you're responding to.
Okay, I was just going to go back to the concept that the Big Bang has a universe with no gravity in it for quite a while, and then it's got gravity, and that in itself is so far beyond any kind of belief that I think it's.
I don't really think that's true, but why do you think that? That's more of an important question. Why do you think that? I mean, from their point of view, they think the whole theory is basically a theory of gravity. So what they're saying, the Big Bang to them is all about gravity.
Okay, well, I don't know. We've read different things. Somewhere I got that impression. I don't know where. I think I read it. I think it was explained that gravity is introduced later on. That in itself got in my mind. I have no idea where it came from, but I think.
Well, I think the issue here is that what it's kind of modern science, and what they're saying in cosmology is sort of ununderstandable to a certain extent.
Probably because it's wrong.
Well, that's sort of a value judgment.
That's kind of the problem there.
Well,
I can agree a lot with what Paul is saying. I mean, so Harry, do you think that the universe is infinite, or do you think it has a bound that's defined by whatever the Big Bang did? That's the question.
Well, philosophically, it depends on what you think the word infinite means. The word infinite is a mathematical word now, and that means unbounded. So, you have a problem there. On the other hand, the philosophers, like, for instance, Aristotle and Plato and those guys, they probably wouldn't have had a mathematical definition such as unbounded on the number line. So you really have this question about, what definition of infinite are you using? But I think the definition that people are using today is that infinite means that it's not bounded on the number line. Does that make sense to you?
Well, I was thinking about this as well, and like, what would it mean to have a bounded universe? I mean, if this was like some kind of science fiction novel, and someone and if the universe did have a bound, you know, if the spaceship went up to this boundary, would they just bump into it and they couldn't go any further?
All right.
You know,
you're familiar with this classic that appears on the covers of books. There's this classic picture that comes from the Middle Ages that shows this guy poking his head through the edge of the universe. Are you familiar with that image?
No. What happened to his head when he poked his?
Well, that's part of the irony of the image. But it shows this guy, and he's at the edge of the universe, and he's poking his head through the boundary. Okay, and so if you say there's a boundary, then there's some place where there's an edge. Okay, presumably, because if you say that the number line or whatever it is in the mathematical numbers, there's a number beyond which there is no number, and that is the boundary. So if you do a measurement of the size of the universe, then presumably there's a measure of the size of the universe beyond which there is no number that can be measured. And so there's an edge or a boundary. There's no number beyond the number that's the boundary.
Yeah, but I was asking you, do you think philosophically, of your own opinion, whether the universe has such a bound, or do you think if we had a spaceship and we just launched it out, that it would be able to travel forever in one direction because space has no bound? I mean,
well, mainstream says there's no boundary because the further you go in your spaceship, you'll just eventually come back around to your starting point. The universe is curved. That doesn't really answer the question, you know.
Well,
that's sort of an evasion.
That's another possibility, that, you know, that boundary causes you to curve back, and maybe you'll find yourself suddenly at the other end of the galaxy.
Right. Now, in that case, you would have a mathematical number system, which is, you know, that's a mathematical number system where the number goes back to zero. So instead of having a number line that's straight, and you just keep going out until you get to the last number there is in the numbers, in a cyclical number system, you go back to zero when you get to the last number, and it repeats. So you have a cyclical number system. And so then that gets you into the question about what type of mathematical model, you know, applies to the universe. Is it a Euclidean straight number line that goes on forever to infinity, meaning there's no bound, upper bound, or is it cyclical or repeat? What Michael said sounded like it's cyclical and repeating, but I didn't really understand what he said.
No, I think Paulo was just arguing that space is in fact completely infinite, so that if I launched a spaceship, it would in fact be able to travel forever, never reaching any boundary at all. Right, Paul?
Yes. Yes. Not only do I think there's the two things, infinite or finite, and I think that using the finite has made physics a place where you could play with all kinds of things, and you know, they've got expanding universe and recontracting universe, and they've got so many things. It's a balloon being blown up, and every picture you try and create for this fixed universe causes confusion in the mind of a reader. And I'm thinking that something like what I've given here that focuses on infinity at least is kind of understandable to somebody in a grade school that wants to start thinking about the universe. You can think about it this way, and then you can expand into the various things that are parts of my subsequent papers. And as Harry said, so much of what's in physics today is just hard to understand and just so specific that it doesn't mean anything, bottom line. Infinity is an impossible concept, of course.
Well, Aristotle sort of tried to resolve that question by talking about what is called the potentially infinite. So Aristotle would have said that if the universe is bigger than we can imagine it, therefore it would be infinite. But that definition being that it's bigger than anything we can imagine it to be. And by that definition, I think that's what Franklin's saying.
Well, I think even mainstream would have to say that space itself physically must be infinite, because so mainstream is explaining that the existing visible universe came from like a big bang and it's expanding out into space. But in order for it to do that, I would think that space itself would have to be unbounded to allow the universe to expand into it, right? Because if the universe itself was bounded, it would hit the edge.
I see that. I just want to make one comment about this, Franklin. If you're doing the Big Bang Theory, you have to understand that you're starting with something that's finite as your starting point. So in other words, they're saying that there's a finite starting point, and you can't have something that starts at a finite starting point as not being finite as it evolves. So they've really trapped themselves into finiteness by the hypothesis or the postulate that they start with. You understand what I'm saying?
Yeah, I think I said that very thing when I said that people like to think forward infinitely, but they don't go backward and think infinitely.
Right. So basically, the starting point kind of limits your where you can go from, and yeah. So that's a good point, Paul, and I think that needs to be more emphasized a bit more.
Well, I'm sharing here a picture of the Hubble Deep Space image here. And what they did is they pointed the Hubble telescope at the most emptiest spot of sky they could find for like 10 days. And, you know, this is what they saw. They saw like 10,000 galaxies for as far as the eye can see. You know, this is basically, you know, Paul mentioned Olbert's paradox that the entire sky should actually be lit up brightly because there's going to be like stars and galaxies everywhere. Every single little dot in this picture is actually a galaxy. So pictures like this, I think, support the idea that space is not bounded, that space is actually, you know, it looks just like this Hubble space picture, that there are galaxies.
By being unbounded, you mean that you can go as far away as you can possibly imagine and go, but you can go even further no matter how far that is? Is that what you mean?
Yeah, I would say that no matter how far you travel in space, you get the same kind of picture.
Well, they say that's not true, so we got to be careful about that.
Well, again, I'm saying that's my opinion. I'd say that my opinion is that I would prefer to think that the universe is actually unbounded, because I think that solves some problems. Like if you say if there was a Big Bang, then you kind of have to explain, you know, what caused that and where is it going. But if you accept that, as Paul is trying to argue, that space is just simply infinite, and that's always been there, like there is no beginning and there will be no end, then I think that simplifies things a lot. But I think that's Paul's point, that he's trying to say that mainstream has gone so far away from that concept that we need to basically bring back the alternative, which is that the universe didn't have a beginning, and that all this Big Bang stuff is just, you know, wrong.
Well, how about misinterpreted?
No, I think the Big Bang stuff is definitely wrong. They've misinterpreted the main experiments which try to do that, like the CNPS. I mean, you mentioned that that they have this experiment and it matches the theory, but actually the CMBR is actually a big problem for the Big Bang Theory, because the Big Bang Theory predicted that there should be completely smooth cosmic background radiation. And so I'm showing the picture of the cosmic background radiation here, and you can see it's anything but smooth. It's smooth, same color everywhere, right? That's basically what Big Bang cosmology predicts, because there's no way they can have it do anything else. And so this picture basically disproves Big Bang cosmology. But instead of doing that, they've adopted things like these inflationary things. They've added it on to the Big Bang Theory so that it allows for this kind of variation in the CMBR. But I think that's just a bunch of hooey. I mean, this picture should have totally blown away and caused the discarding of the Big Bang Theory entirely, since they just basically fundamentally are not supposed to have anything that looks like this. I mean, I think that's probably why they did this experiment, because they were expecting to see a smooth background, and instead they got this thing. So, but yet that didn't refute the theory. They just added more junk onto it in order to make it fit. Now, me personally,
well, once you've committed to a particular theory, it's difficult to admit that you're wrong.
Yes, even when you get a clear experimental result that shows, yes, you are completely wrong. So
that would mean they'd have to, toss out all the textbooks.
Yeah, so they don't want to do that, so they just added on a bunch of other ad hoc stuff in order to make it work out. So that's what we call ad hoc, and that there's no reason for it other than to save a failed theory.
Okay, I want to go back to Paul again and ask Paul a question here, Paul.
Yeah.
Why do you start with, in your paper, why do you start with dealing with the universe as being infinite rather than at the end you talk about the nature of space? Why don't you talk about space and what space is? Because it would seem to me, although we don't really know what space is, at least we know more about space around us than we do about the universe far away.
Well, first of all, I wrote a lot of stuff on this particular idea of just starting with the definition of the universe as the whole body of things and phenomena observed or postulated, which is everything. And then I tried to look at it a number of ways in this particular paper, and you guys are just adding a whole bunch more. And as you said, it's very hard to think about talking people out of their belief in the Big Bang and the rest of the theory. So that's why I made this long in the first place. And why did I start here? Because I don't, who's going to look at my theory if I'm going to tell them that starts with things like gravity having a nature and pushing things and causing orbits and explaining a lot of things that are not explained in current physics. Well, they don't care. They have their perspective, and it's a huge adjustment to think my way instead of their way. Took a long time to think through some of the things that I've got. And so I said, well, you're not going to get there unless you accept infinity.
Well, you do realize that that leads to a lot. The concept of infinity is, in mathematics, is like the death blow to mathematical systems. I think, what's his name? Bordeaux or whatever, Gödel kind of, pointed that out pretty effectively. You aware of this?
Say that again. Mathematics does?
Well, it turns out that if you allow infinity in mathematics, you produce all these, contradictions and problems to a mathematical system. So it's a lot neater if you don't have it in there.
Okay,
well, the one point I wanted to make was that whether the universe has a bound or whether it's unbounded, as far as we're concerned, I don't think it makes much physical or physics difference. Because from at least visible light, that if there's a boundary, it's at like 16 billion light years away. And that boundary is not going to have any effect upon the physics that happens upon the Earth, whether there's nothing beyond that 16 billion light years or whether it extends on infinitely. I think the bigger point here is whether Big Bang cosmology is correct in that basically saying there's no matter, no visible matter past what we can visibly see for 16 billion light years. But physically, I mean, if there was a boundary, I mean, if God made it just like this box and when you got out to the $16 billion year limit, you just stop. You've got a spaceship, it would just you couldn't get any further. Then I still don't think that would make any material difference upon our physics.
Well, they get around that by saying it's unbounded, you say.
Well, it could be. My point being, it could be bounded, could be unbounded. I'm just saying, don't make any difference, really.
I think it's kind of
it's so far away from us.
My point to Paul was, I don't really understand why he was starting off with that, because that's kind of like, I mean, I don't really think it's not something that you can really get a hold of, the infinite thing, the infinite, when you start talking about infinite, you can't really get a hold of it. It's ununderstandable, as he was saying. So why would you, it's just like something that people can talk about and philosophically contemplate, but you can't really resolve it or get a handle on it or prove it or anything like that.
I think that it's closer to say unbounded rather than infinite, because infinity, with the infinity sign, you would actually not encounter that unbounded space, because you would continue to move finite distances through space. There's no such thing as infinity mathematically in a physical space. I don't think that, in physical space, you have to move finite distances. So we're just saying that you could continue to move finite distances for as long as you care to move.
So you have a sort of Aristotle potential infinity.
Potential. I think what Aristotle said, potentially, because it makes no physical sense to ever have an infinity, right? That's the problem.
Well, he's saying it's just bigger than we can imagine. That's what potential infinity is.
I'm not sure I quite agree with that. I mean, I can agree with a lot of things that Paul is saying. Although one thing I want to ask Paul, so one thing that I violently disagree with is your concept that space is made out of basically the electromagnetic radiation. And space is made out of radiation. So I know, Bill, you might want to get into this, because this is actually exactly the way you feel that space is. So I'm not saying that that's anything unusual, but I just violently disagree with the idea that space itself is made out of the observable radiation, like the light that's coming off this lamp, that space is made out of the rays that are coming off my light bulb. I completely disagree with that. I mean, from a logical basis, we know that this electromagnetic radiation does possess the characteristics of frequency, right? It has an amplitude. We have electronic instruments, you can put it on an oscilloscope and you can measure that things like even things that seem different, like radio waves and light waves, have this measurable and unique frequency. It's not like light waves have one set of frequencies and radio has another overlapping set of frequencies. No, it's the same whole measured spectrum that these things have this characteristic. And logically, if you've got something and it's a wave phenomenon, it has different intensities, right? This is different amplitudes. So the only way that can occur that we know of is if there is a medium, and we understand how, say, sound waves work. There's no question about how a sound wave works. And we understand that it works as a compression of an actual physical medium. There's air. There's particles of oxygen and nitrogen that are being compressed and rarefied, right? So it is a logically contradicting to say that these waves, the electromagnetic radiation, can exist without any such medium, which is what you're saying. That we have electromagnetic radiation, has a frequency, acts like a wave, very similar to sound, but yet has no medium. You're saying that the electromagnetic wave itself is the medium, which I believe is a logical contradiction. It's like a coin that has one side. It's a logical contradiction. The existence of wave logically implies the existence of medium. That's why I disagree with this whole concept that space itself could be made out of electromagnetic radiation.
In electrodynamics, the waves are waves in the field. Not.
Can't hear you, Bill.
Okay. In electrodynamics, the waves are in the field. The waves are no different separate from the field.
Bill can't hear you.
Not sure why that is.
Well, Bill is saying that the electromagnetic waves are waves in the field. Now, I think that's you're just kind of pushing, you're kind of kicking the can down the road, because then you have to say what the field is. I think Paul might go a little bit further than you, because he's saying that the field itself is actually all made out of the gravity waves, the light waves, all the electromagnetic things that are going around.
Are you ready for my
Yes, Paul, I want to hear what your answer is.
Okay.
My challenge.
Okay. First of all, and more of this gets into my later papers, but we'll talk about the spectrum of the wave spectrum, which has all these different wavelengths. And of course, we see the light, we see the different colors of light. And so the number of waves possible on beams flows in both directions. You can have more waves, you can have less waves. Now, the part that I originally built things around has to do with the long waves. And the long waves are something that we cannot detect. They are longer waves than any of the sound waves and so forth. They're extremely long waves, but they exist. So we don't see them out there, and they can be your base of space. But the point is that there's kind of an I define the spectrum as a spectrum of existence. And I have a paper right here, if you want to go through it soon, discussing the electron, which gives you how high frequency waves convert into matter. So you've had matter on the top end of the spectrum, and when you get into the long waves, you've got that which creates, which gives the basis of space itself, and the longer waves, the more likely the wave is to penetrate matter. And so there exists just as many long waves as there are light waves out there, and they penetrate matter, come through the other side, get modified, get more waves, become the push or the push of gravity, which
that doesn't at all address my logical problem, which is even though you have these super long waves that can't be measured, as a wave, there has to be something which is being compressed and rarefied so that that wave can be physically represented. So that wave itself cannot represent that medium. I'm saying there must be a medium. If you're talking waves, there must be a medium.
The medium is...
The wave itself cannot be the medium.
Everything flows... everything flows in space, and it's given the light frequency when it goes through planets or stars, but it existed from day. It's always existed, radiation. It's always flowed infinitely everywhere, and it's always. If there weren't any matter out there, it would all be this long wave. Such a long wave that you don't really even see the waves or imagine the waves. The radiation is just there, flowing everywhere.
Yeah, but how can it propagate without a medium? I don't care how long it is.
It propagates. It has always been everywhere. It is the basis of infinity, and it flows everywhere and always has.
But that's irrelevant.
It doesn't change. It doesn't change anything until its frequency has changed, but it's still there. It's the same.
My argument is a logical argument. See, I don't have any problem with it always being there and it being infinite. That's fine. But that still doesn't explain how it can have a frequency without traveling through a medium. I'm just saying there must be a physical medium. I think Harry, I think correctly states that whenever we talk about stuff like this, now he doesn't understand what you're talking about because there's no way that, like I can understand a wave that travels without a medium. So I think and the reason why you cannot answer that is because you can't, because a wave cannot travel without a medium. There must be a medium.
The medium is all the other waves.
Yeah, no, all the other waves still rely on a medium as well. Every one of those, you can't have wave riding on a wave. I mean, a wave, no matter what it is, I'm just saying that's illogical.
They create existence.
Cannot be riding on other waves.
All the waves at any point create the existence of that point by passing through there. And so all the waves passing through all the points create the medium. It's the sum of all the points that makes the medium that all the waves travel through.
Now, a wave needs a medium which is distinct from the wave itself. A wave is a physical reality upon the top of a medium which can be rarefied and compressed. Right? Now, you've got this compression, you've got this rarefication. This is what we measure as a wave. And that itself cannot be the thing that is being rarefied or compressed. Typically, we require a physical medium for space. Now, other people have tried to come up with a physical medium, like Dirac suggested an electron. See? Well, I don't think that's particularly correct. I mean, you could make a C out of, I don't know, protons, but I'm not sure that that's correct. You could make a C out of, say, hydrogen atoms. And all of those things would work to be a medium for a wave. But to say that the waves themselves are the medium itself, that logically doesn't make any sense to me.
Well, any one wave that you talk about can flow through the sum of all the other waves.
No, they can flow by the other waves. But
Okay,
it's still, they all
they
have to
flow through
be in a
them.
medium.
They
A
flow
wave
through.
cannot be a medium for another wave.
That's the problem with your thinking. You've sort of defined things in a certain way.
Yes, in a way that we
changed the
observe
definition.
physically. That's like me saying the sound waves that are coming out of my mouth are being, the medium for that is all the other ambient sound waves that are around me. And that just seems silly.
Not just sound waves, but all the waves.
William Hooper did experiments on the electric and magnetic field, and he measured 14 characteristics of electric fields and magnetic fields. And what he found is they have tensile strength, and they are continuous. They are not made of particles or something, small bits or something. And when Arthur Compton and his last graduate student, Winston Bostick, did experiments with the electric field, they were able to make what are called solenoids. And these are continuous loops in the field. They seem to form the basis for all waves. So sound waves, for instance, are waves between where molecules and atoms are involved, but it's the electromagnetic field that enables them to interact and to produce the sound wave. The sound wave is a secondary or tertiary level wave, whereas the electromagnetic waves travel much faster because they're stronger. And so those experiments that they did would say that all waves, the medium for the waves is the electromagnetic field, and it does not have the property by itself of mass, but solitons, which are very long-lived standing waves, when they bind together, their kinetic energy of vibration defines what we call as mass. So that's another approach to this, and it looks like the experimental data is in support of that approach. And I think the other theories are lacking experimental data for their what is the origin of mass, what is the origin of charge, and these things.
Well, the thing is that your whole theory there suffers from what's the origin of the electromagnetic field?
And the origin is explained by the first great proto-philosopher whose name was Mochi or Moses. And
now you're just going to say that the electromagnetic field is defined by God,
well, no,
which is probably true, but that still doesn't explain what it is.
Property of God. Yeah, and
I think it's much more probable, more logically satisfying, is if you could find an actual physical medium for space. Now, a lot of the dissident scientists will do that. I mean, they make up all kinds of particles to represent what this medium of space is, and I would be fine with all of them as long as they could, actually find their particle that they're claiming space to be. Although no one's really found it per se.
With those theories, like the Standard Model of Elementary Particles has between 19 and 29 adjustable constants representing unknown physics. Electrodynamics has no adjustable constants representing unknown physics and seems to explain all physical phenomena that we can observe, including life. And so,
well, except you can't explain that whole what's the origin of the electromagnetic field itself, which is a gigantic hole that you could drive a truck through.
Yes, but that is we have to take that, I guess you would say, on faith and observation. The observation agrees with the concept that the origin is with God, and it also appears that the universe has a center, and that center may be related to the center of God But you know how we have
it looks like Michael's raised his flag here, so as an etherist, I'm sure he has something to say.
Well, it seems to me that talking about medium and about waves, that everybody's kind of dancing all around the issue of the ether. And of course, I'm an ether theorist. And as far as creation goes, I think my theory is that the ether came first came oscillations of space, then ether, and then after that, creation of our quantum atomic world.
Oscillations of space without an already existing medium. This is the same problem that I'm presenting to Paul. You can't have waves without a physical medium to represent its amplitude, so you can get a frequency out of it.
Massless units of ether. Massless came from original space, which was free of forces and therefore probably more self-compatible than space is now. And then,
but you can't tell me what that particle is, man. You can't tell me what its relationship to, say, an electron or a quark or a proton or a neutron. You just have to say it's, you know.
Well, in my model, there's no such thing as a particle, or it's a particle is a particle capacity. A quantum or atomic unit was created out of the ether via entrainments and linkages of elemental ether units, and that's where everything comes from.
And how come we haven't seen elemental ether units in our accelerator experiments? That's exactly what we're trying to do. We're going to smash together anything, and
the ether is too rarefied. We can't detect it. There are such things as quasi-particles that they don't know what they are. They suddenly appear, and they can't explain what they are. They seem to be similar to bosons and fermions, but they don't quite fit. And in my theory, these are etheroidal units which have fallen out of the vibrational pattern of the ether, and they appear in our quantum world of fields and waves and vectors and spin. And
but you're saying they do appear, right? We don't recognize them. I mean, that's okay. That's something you can go look for. If you could theoretically predict what these things would look like, then that's something you can experiment with. But I don't know. I'm always really suspicious about when people say you can't measure this. I mean, not even theoretically kind of stuff. I mean, that's just waving your hands and.
Well, we're in a quantum atomic world, and that's our kind of ambience. The energies that we deal with are quantum forces, and the ether is vibratory. It's different. It's inherently different. It acts differently. You can explain quantum entanglement of quantum units.
It's got to explain this electromagnetic field. So,
well, if you have an ether matrix, and it's made up of these elemental units, and if the quantum units are also made up of the elemental units, then you can have an entanglement explained by the vibratory resonances of the matrix elemental units with the elemental units that make up the quantum units. So this is
I don't really see any difference between what you're saying and what Paul says.
I mean, everything that you just said there about entanglement, that makes zero sense. That's completely accidental. So
let's get to we're talking about Paul's theory.
Yes.
But Michael seems to be saying the same thing that Paul is saying, and I don't really see a difference. Can you explain the difference?
Well, what Paul is saying is you have all these waves, and I'm saying that the waves are an effect, and the cause is the ether. And there's an ether matrix, which is composed of vibrational energy.
Why can't the waves be the cause, which apparently is what Paul is saying? Is that correct, Paul? Or you're saying the waves are the cause?
Yes, I'm saying the waves are the nature of all space, and that they are essentially the answer to everybody's search for an ether. The sum of all the waves at any point is an ether, if you want to call it an ether. This solves the situation where nobody knows what the ether really is.
Well, except that any wave requires a medium, and this is the logical contradiction that makes your that makes your theory seem incorrect.
No, what do you mean? The waves together make a medium.
No, the waves themselves cannot make a medium by any physics that I know about.
Why?
Any wave that I know about has to be mediated by a physical medium.
They all moved. They all flowed. That's what they
The
do.
only way they can move is by reference to a physical medium, a particulate medium, in fact.
Well, but that's where you get into trouble. So you're using particles.
Things that exist in the real world, like the air in this room, particles.
Yeah. Okay.
So I think it's perfectly fair to use things that we can actually touch and see and measure in experiments.
Okay, but you've got that with radiation. Radiation's everywhere. Radiation fills the skies. You want to put in an antenna. You're going to get all kinds of various frequencies of radiation everywhere. So it's just everywhere. And since it's everywhere, it might as well be the ether, which everybody seems to need to.
No. As an etherist, the wave is a phenomenon upon the ether. It cannot be the ether itself, right? Now, the only difference between me and Michael is that I think the ether is basically neutrons. Michael thinks that the ether is this primordial stuff that eventually becomes particles that we see. So I think that's a relatively minor difference, but still there has to be at least a physical particle of some sort, be it a primordial ether particle.
It's a vibrating It's a vibrating energy unit. And
it's just saying that your theory is not at all satisfying to it. It does not answer the question of what is the ether at all. Just saying.
Elemental units that vibrate and the outward vibrations resonate. That's what it is.
Yes, well, that's what your fundamental ether particle is, but I would just call that the electron, the positron, really. So. Makes it more physical to me. I like to use the particles I actually know about rather than some.
I understand this idea that you need to have something physical to be the medium. Unfortunately, it seems to me that that's just a philosophical principle and not really a physical.
No, I think that
says the world has to be that way.
That is an absolute physical requirement for,
as you say so,
logically speaking, because it's got an amplitude, it's got a frequency. There's got to be a way we can measure these things, and you put a radio antenna out somewhere, and you can measure these things. I mean, something must physically be impinging upon the receiver rod of our radio receiver. Something actually must be physically hitting it.
Depends on what you mean by physically doing it.
I mean, like particle A pushes particle B. That's what I mean by physical.
Well, a lot of people.
But you need particles. The point is here that you need particles to make your ether. And that goes throughout all these years in which the radiation has been given no is not matter because it doesn't have any
Yes.
Well, that's perfectly consistent with a wave.
So, but a wave really has to be made up of something in order to exist and to flow. And so therefore, if you forget there's this big distinction between matter and radiation, and you just really realize that, radiation's doing the same stuff, but it just, you can't weigh its in any way, but otherwise. So therefore, it is your particles. At some level, it is your particles.
I mean, people like to try to mix those things up. That also why I'm just violently opposed to this entire idea that matter is somehow made up of waves. That is just another
Okay, well, you're not going to like my next paper then. I've got a paper
that is probably one of the wrongest things anyone could probably ever think, in my opinion. That's just my opinion, though.
Well, that puts you in a pretty tough spot considering all the evidence that refutes you.
Like what?
I mean,
like what? Name me 5.
Well, there's wave-particle duality. I mean, that's pretty well established.
Yeah.
Well, one thing that we're not paying attention to is without continuous medium, you cannot have a wave. And the only continuous medium we know of is the electric field. And if you don't have an electric field between particles, you can't have any kind of wave.
Yeah, so there must be a physical medium between every particle that makes up this electromagnetic field.
No, but
what does physical medium mean?
Physical medium.
The field.
What does physical medium mean?
Made out of particles.
Okay, there you go.
Physical particles, like protons, electrons,
neutrons,
something
mass,
that we know
right?
about.
You mean mass?
Yes, must have mass. Yes, must have mass.
So it has to be a bunch of objects.
And waves. Particles have mass.
So space is full of a bunch of particles that have mass, and that would mean that it's solid and you can't go through it.
No, it could still be like a gas. I mean, you could consider kind of the space in front of me as solid because it's uniformly filled with these particles, but yet my hand passes through quite easily, right?
Well, I would assume that the inertia of the universe would be pretty massive, so you couldn't really pass through it if it was made of solid massive particles that have mass.
Well, people have argued that some people in the etherist community think that the ether is in fact a solid, which means you have like a crystal matrix and that the particles don't really move relative to each other. But I'm thinking that if you had a solid ether, then you would be correct, because my hand would be completely stuck in space because it would never be able to push past the medium. But I prefer to think of it as, say, a sea of neutrons, or what I call positive electrons. They're just a loose sea, and if any pressure is applied to these particles, they simply move aside and they get out of your way so that you can move your hand through space easily. However, you still have to exert energy to shove these particles out of the way, and that's why this is what causes basically inertia, and that if I try to push like a car, even if it's frictionless, that it still takes a lot of energy to get it moving because you're trying to shove a flat side all of that, those physical ether particles that are in your way.
Now, all of your ether particles require an electric field. They have a charge. Even a neutron has a magnetic moment and a spin. And those are all electromagnetic phenomena. So you don't have any particles without electromagnetic fields.
Oh, yeah. All the particles, I mean, if it was a field of neutrons, then sure, that the electromagnetic field would be there, but of course it'd be totally neutralized. No, you would never really see the effect of it.
The magnetic field, that's part of the electromagnetic field. And, so there's no medium we know of that doesn't involve electromagnetic field, and as far as we know, that's the only medium that is continuous. And you can't have the action at a distance is impossible. You have to have some kind of continuity to convert or transmit forces between particles. And so the most fundamental thing is the field, not the particle.
No, I think that logically that doesn't make any sense at all. We know every field that we know of, like a field of corn, contains particles, right?
Well, it's only illogical because you don't comprehend it.
The field of any other field that we know. So logically, the particles must come before the field. You're really sticking the cart before the horse by saying that the field is fundamental.
Well, not actually, Franklin. It's just that you don't really see it that way. You want to see it in terms of, because I have a wave, I have to have a medium. And this is kind of the mantra of every ether theorist. If I have a wave, I have to have a medium. And they can't conceive of a wave without a medium. And
well, if you can conceive of how to have a wave without a medium,
particle that has a mass. So
Well, let's see here. We're
you're
getting
just
towards
trapped
the end of our meeting.
in this way of thinking. That's all.
We're getting towards the end of the meeting, so Michael has a comment here, so I'll let him comment, and then we'll have to close out the meeting here.
Going
ahead,
back
Mike.
to your idea of the ether as a solid or as a fluid, that would disagree with gravity, because if there is an ether matrix or medium, gravity would have to be due to a contraction of the ether between bodies. And the only way you could have that would be if you had a vibrating ether, like I proposed, vibrating units with tiny spaces in between them, which close off when they resonate. And you couldn't have that with a solid or a fluid ether.
What are you talking about? All fluids, by the definition, have to be able to contract and rarefy and compress.
Oh, all right. You said solid ether. Maybe I interposed the fluid incorrectly. But you did say solid ether was one theory, and I don't think that could be.
Well, that's not one that I particularly agree with, because there's
around that by saying sea of ether particles. So ether is not a solid. You just say it's a sea of ether particles, and that escapes that contradiction. To me, that's just language.
Yeah, well, there's a difference between solid and a fluid. We can all understand.
All I see is that ether is just a rhetorical word that people say because you have to have a medium, and then they try to start giving properties to it, like, well, there's an ether particle, and the particles behave in this and such a way. And I don't really see that there's a need for any of that. That's what Bill Lucas is saying, and I think Paul is saying the same thing.
Yeah, Bill and Paul are kind of saying similar things, that the electromagnetic field, it's like electromagnetic field is what Paul is just considering the conglomeration of all existing waves.
No, he's saying more than that. He's saying that there's a universe of waves that are passing through, that exist, that create the medium, which...
Yeah, that's basically what he's saying.
I may be wrong, Paul. I'll let you try to say it again. I heard you. I'm not really sure I understand it, but from what I understand, what you're saying is you're saying there's an infinite frequency of waves, from long frequency to very short frequency, and all of these waves exist simultaneously, and they pervade all of space. And because they pervade all of space, that is what creates space.
I think that was a very good summary on my idea of space, and I think that all of this discussion about some particles creating the ether always runs into these troubles, as you've mentioned earlier. And if you just use waves, which there's as you also mentioned not too long ago, there's the wave particle equality. Then you can take the wave part of this and the few things that the waves differ in terms of no mass as they were originally defined, and therefore they're a little bit more of just a flowing than they aren't. You don't make pieces out of them, really, so you don't run into all the particle problems. And yet they're everywhere because they're coming from everywhere, and they're all different kinds are possible, and so they all merge together. So you've got the ether. And why are we so worried about this not fitting into what people that want an ether fitting for? And I have one other statement separate here. You know, Franklin, you're not too happy about some of the things here, and you also said that you don't like the creation of matter from radiation. And I've got a paper that I wrote this week that's called "What is the Electron?" and I thought maybe I'd be consider giving that next week. Okay.
All right. Well, you can. I think that would be an interesting discussion about, because there's a lot of controversy as to the nature of the electron. I would continue to argue that it's completely fundamental, but I'm welcome to hear anybody else's argument. But we are running late on our conference, so I am going to have to. So, Paul, thank you for your summary there, and thank you for coming and talking to us about the nature of infinite space, and that there's no Big Bang. Okay. But hopefully we'll see you. Let's see. I'm going to actually be going on vacation for the next 2 weeks, so we may have. So, Bill, you may need to fill in for me for those next 2 weeks.
Yes, I can do that for you.
But there's no meeting next? Okay, fine.
But until then, we'll see you at the next conference. Just watch out for meeting announcements.